Hello everyone! Today I'm going to talk about how to analyze a function using its first and second derivative. We always start with the original function, f of x. Here's our equation, f of x equals x squared minus 9 divided by x plus 7. Let's start by factoring the top. This factors to x plus 3 and x minus 3. Now we can find out where the roots are. The roots happen when the top equals 0. That occurs at 3 and negative 3. Let's plot those on the graph. There's negative 3, there's positive 3. The function is undefined when the denominator equals 0. That happens at x equals negative 7. This is our vertical asymptote. Let's plot that on the graph. The function will get really close to this line, but never touch it. Now let's go on to the y-intercept. By making all the x's 0, we get negative 9 on top and 7 on the bottom. So we get a y-intercept of 0, negative 9/7, which is approximately here. Now, since we have a fraction, we have to worry about end behavior. To find the end behavior, we do long division. By using the box method, we have x plus 7 on the left side, and this x squared in that first box. X times what gives us x squared? That would be x. X times 7 is 7x. Now you notice we don't have any x's in our equation, so that means we have to subtract 7x to make them cancel and equal 0. X times what gives us negative 7x? That would be negative 7. Negative 7 times 7 is negative 49. To get negative 9, we have to add 40. Our answer is x minus 7 with a remainder of 40. The remainder doesn't matter in our end behavior, it's just this part right here. So our end behavior function is y equals x minus 7. Let's graph that line. This is our slant asymptote. Now let's look at the limits of the infinities. As x gets really, really big, imagine plugging in 1,000,000 into this equation and then you square it. That's an even bigger number, that's 1 trillion. So our function goes to positive infinity. As x gets really small, the top is always positive, but the bottom, if you plug in negative 1,000,000, it goes to negative infinity. Okay, let's plot those on the graph. Now let's go to our derivative. We have to use quotient rule to find the derivative. Derivative of the top is 2x times the bottom, x plus 7, minus derivative of the bottom is just 1, times the top, x squared minus 9, all over the bottom squared, x plus 7 squared. Let's simplify this a little bit. 2x times x is 2x squared. 2x times 7 is 14x. Distribute the negative. When you combine like terms, you get x squared plus 14x plus 9 divided by x plus 7 squared. Now we want to find the critical points where the top equals 0. You have to use quadratic formula. And you can just plug those numbers into your calculator. You should get negative 0.675 and negative 13.325. Let's make a sign chart. We have to plot the critical points and where the function is undefined, which is at negative 7. To the right of this point, we know as x becomes really big, it heads to infinity, meaning this section is positive. You could also plug in a number greater than negative 0.675, like 0, into the derivative if you're unsure. Since this is a regular point, the sign switches to negative. Since we have a squared here, the sign stays negative. Since this is a regular point, it goes back to positive. Again, you could just plug in numbers if you're unsure. Negative 2 here, negative 8 here, negative 15 here. Now we can use the sign chart to tell where the function is increasing and decreasing. The function increases from negative infinity to negative 13.325 and negative 0.675 to infinity. Since the derivative is greater than 0, it's positive in those sections. The function decreases from negative 13.325 to negative 7 and negative 7 to negative 0.675. Since the derivative is less than 0, it's negative. We have to exclude negative 7 since it is our asymptote. Now let's find the minimums and maximums. There is a relative max at x equals negative 13.25 since the derivative changes from positive to negative. There is a relative min at x equals negative 6.75 since the derivative changes from negative to positive. You always have to write these sentences when doing function analysis. Let's go back to the graph. This is what we just found. It is increasing from negative infinity to negative 13.325, which is on this interval right here. It is decreasing from negative 13.325 to negative 7, which is on this interval. It's still decreasing from negative 7 to negative 0.675, which is on this interval. And lastly, it's increasing the rest of the way, negative 0.675 to infinity. We know we have a max at the point x equals negative 13.325, but we need a coordinate point. We have our x value, so we need to find the y. We have to plug this into the original equation, not the derivative. Here's our original again. If we plug in negative 13.325 into the original equation, you get negative 26.649. And you do the same thing for the minimum. Plug negative 0.675 into the original equation, you should get negative 1.351. Let's plot those on the graph. Here's our maximum, negative 13.325, comma, negative 26.649. And here's our minimum, negative 0.675, comma, negative 1.351. Let's go on to our second derivative. Here's the first derivative again. We have to do quotient rule. Derivative of the top is 2x plus 14 times the bottom, x plus 7 squared, minus derivative of the bottom, move that 2 out in front, times x plus 7, times the derivative of the inside, which is just 1, times the top, x squared plus 14x plus 9, all over the bottom squared. So now we have x plus 7 to the fourth. Let's separate these. I factored out an x plus 7 from the 2x plus 14. And we have 2x plus 7s on top, 4 on the bottom. So we're left with 2 on the bottom. Now this part, we have 1x plus 7 on top, 4 on bottom. So we're left with 3 on the bottom. The rest stays the same. Let's cancel out 1x plus 7 here and 1x plus 7 here. Now we need to make a common denominator. If you multiply both the top and bottom on this one by x plus 7 squared, you'll be able to write the whole thing over x plus 7 cubed. Now let's FOIL this out. You get 2 times x squared plus 14x plus 49. Now let's distribute that too. 2x squared plus 28x plus 98. These two cancel. These two cancel. We're left with 98 minus 18, which gives us 80. So our second derivative is 80 divided by x plus 7 cubed. Now let's make our sign chart again. It is undefined at x equals negative 7. There are no other critical points. If you plug in a value less than negative 7, you will get a negative number. If you plug in a number greater than negative 7, you will get a positive number. The function is concave down from negative infinity to negative 7, since the second derivative is less than 0. The function is concave up from negative 7 to infinity, since the second derivative is greater than 0. Even though we see changes in signs, since the function is undefined at x equals 7, there are no inflection points. Let's go back to the graph. Here's our second derivative. This is what we just found. So from negative infinity to negative 7, it is concave down. And from negative 7 to infinity, it is concave up. Now the last thing we need to do is graph our function. You'll notice that everything that we found applies to our graph. That's all I have for today. Thanks for watching.